Hello everyone. Today we'll discuss Unit 4 Concept Exploration and Development. The unit focus how a idea is shaped, tested and redefined into the complex working design is ready for the manufacturing. We'll explore how solid modeling, assembly modeling help visualize design accurate and how product architecture organize functions into the physical part and how design for assembly and design for manufacturing make production easier for cost effective. We will also understand the role of ergonomics which is ensure that the design is comfortable so safe for human, and finally we'll have the part print analysis complete design with the actual manufacturing in this unit. So in this syllabus topic, solid modeling and part assembly, product architectures, digital product design and part assembly with respect engineer drawing definition, classic of engineering drawing, element of production drawing and bill of material, types of dimensional, argument dimension, principles of determining limits, weights, tolerance, geometric tolerance, datum systems, design for assembly, design for manufacturing, design for process, product design step introduce and ergonomics in the product design, design review part and print analysis. So that's unit CO is understand the process, tools and techniques for the concept exploration and development in that syllabus. So there is a question paper of November December 2022. There is question of product modularity and types of modularity, BOM with example what is tolerance, so product architectures, what is dimensioning, what is fate. In May 2023, what is the ergonomics in designs, what is BOM, what is limit tolerance, fate, what is product architecture, what is need of engineering drawing, what is fates. Solid modeling and part assembly. So CAD model and programs are used to database for the primitive forms the solid geometry like a cubes, cones, cylinders, pyramids, sphere, etc. There as a combine in varieties of the way adding the subtract to the product more complex model. So solid modeling is one of the important tools in computer-aided design. In the process, software use basis a 3D shape like a cube, cone, cylinder, bulb, and complex. These shapes can be added the subtracted from the detailed model. Unlike simple surface and wireframe models, solid models give exact information about the volume, weight, dimension because the geometry is well defined. Engineers can analyze the mechanical and dynamic behavior even before the making a physical prototype. In this approach help the reduce the error and improve the quality of the design stage. Gives the well-defined model. So volume already say calculate the volume complex place prevent the problems. It is just a question taking about the volume and confrontation prevent the adding the subtraction then the approaches so volume so that weight you know that begin the design process and lead to no wrong. So solid modeling geometry basis on the for engineering analysis because the geometry is well defined. So integrated between the CAD and engineering is very important concurrent engineering because it is make the more integrated step possible during the design. So many changes during the design process is possible. There will be help to optimize the product. So importance of the solid modeling but so they will be benefit for the solid modeling accuracy. All geometrical data surface angle volume are stored in a precise in the systems. If we need to make a design changes it can be done quick without redrawing or entire model. The model can be directly used for the simulation stress analysis motion study for integrated between the CAD analysis for the tools from the base concurrent engineering where the designs and testing happen together. Ultimately, this speed and development will give better the quality product and lower the cost. So assembly modeling further build for the solid modeling and combinations of solid modeling together into the overall assembly model. Individual part of the solid modeling data file describe the 3D geometry individual component of the assembly together create assembly describe. So whatever get. So assembly modeling take a solid modeling to the next level. So here is the individual part of the model and bring the together from the product complex product. Each part is a positional accurate using the coordinates or meeting conditions like aligning holes, match faces, which is visualize how all part integrated in real life. It is very useful for the checking clearance, interface, and tolerance before the manufacturing. By the digitally, we correct design issue for the early to avoid the costly physical prototype. It is the assembly for the modeling. So next slide. It is the assembly model of CAD model 3D. So basically it is the surface match, tolerance, it is assembly. Here is a nut and bolt for whole assembly. Here are the cross sections of cut section of the assembly. So there is a dimension, it is check interference of here. Whole cut sections are visible in CAD models. So product architectures. So product architectures is a process we create a schematic of product and various sub functions rather than representing the product as a prototype, and prototype is broken down is a base component and the exposed experiments geometrically. It is make a redundancies more apparent and the better experience of the relationship between the different features. So product architecture, product architecture is like a blueprint of the product structure. So instead of the booking at the product in a single whole, we break into the smaller parts, both functional and physical. We are studying how these parts connect the work together, can eliminate the redundant features, improve the performance to make manufacture easily. It give a clear idea of how design element turn into a physical component. It is the product architectures. So product architecture definition. Argument is a functional element to the physical chunk is a become the building blocks product of family of the products. Products module. So module. So so uh, we define the product architecture is argument the product functional element into the physical chunk. Each chunk perform a specific function like a module or subsystems. For example, washing machine, a motor control panel, drums are different chunks. So chunks are connected to the interface such as a electric connection. So mechanical joint which allow that work on the systems. Other terms of the chunks. So chunks is made of the collection of components that carry the various functions sub-functions of the products. Other chunks are attached subsystems, cloud module, or buildings blocks interface the connected chunks together. So the world of chunk is important architecture. It means be a group of parts that together perform one functions in different like a subsystems module cluster describe the chunks. What connects the chunks is called an interface. They define how the chunks interface with the another, whether it is the transferring the motion, electricity, or the fluids. So architectures. So architectures in the product design. The architecture is a product is by scheme by the functional element that product arrange into the physical chunk by the which chunk is interact. So architecture is a roadmap of the functions from the tell us how required the functions will be achieved by the physical part and the how this part will be engaged. A good product architectures can be slow cost, improve the product performance, and make a assembly service easier. It is the architectures. So product development process, the planning, concept development, system develop design, detailed design, testing, production. It is the platform, the decision, conceptual decision, decomposition decision. Product architecture is defined earlier. The product process is not the linear sequential process. So architecture development process. During the product development, once your concept is selected, we need decide one of the product architecture. This stage is effect when is which material to use the product will build, and even how terms will be collaborate for interns when they have handled the control model with another works on the mechanical assembly guidelines of the architectures. So there is the concept is, so first is of planning, second for the concepts, third for the state level design, system level design, so detailed design for testing, then one is a next one is a production. That's where I have the product development process. So architecture decisions for the physical element, modularity, interfaces, product platform varieties, cost and manufacturability, product and product development management, functional elements. So so we are deciding the architectures. We must be make a smart decision. Should be a product allow easy product and the part replacement. Should we aim of multiple product versions or one standard model? So we are want to balance between the high performance and low cost. So finally we'll design the must support a smooth and manufacturing and project planning. These all choices shapes and final product structures. That's where the product decisions will be works. So choosing a product architecture. Architecture is a design related to the product planning and concept development decision. So product change, product variety, standardization, performance, manufacturing cost, and project management. So product change, the copier, tuner, camera lenses, computer, automatic motor, bearings, fasteners, racing bikes, fighter planes, disc drive, razors, steam capacity scale. So product change is camera lenses, copy tuners, so product variety, so computer, automobiles, medical fields, so various varieties of products standardized. So bearings are standardized, motors are standardized, fasteners are standardized. So steels are standardized. So various parameters are standardized. Uh, ones of the model also. So iron press, so the coil of voltage is standardized, so power is standardized. Both it is a both concept as standardized. So performance is the performance of engine, racing bikes, fighter plane, for radial engines, jet engines are the performance. So it is the input work to output work, convert into output work. It is the performance of the, so bikes, fighter planes are that manufacturing cost, like disc drivers, razors. It is the manufacturing cost of products. Project management, team capacity skills. So team capacity skills is a project management teams. So next slide is modular or integrated architecture. Modular and integrated architecture model. So modular architecture, each is the part of the module has the specific functions of the clear boundaries. This make it easier to replace the upgrade module in the how computer was solved. So contract integrated architectures, so mix with the multiple functions within the same part. Smartphone tightly packed with the circuit is integral design can improve the performance, but the harder to the modify or repair. So modular product architecture. Chunk implement one of the few functions entirely integrated between the chunk, as will define the modular architecture has been advantages in the simplicity and the reusability for the product family or platform. So so modular product architecture. So same are make knives. So Sony workmake, it is the examples of the modular product architectures. Tailor examples. So modular architecture. So separately attachment, the body of wheels, light is module, each part of the replace of the redesign implement. So but is a trailer is a frame, wiring and body are the focus of together, that one of the integral architectures. So while may be reduce the weight of cost, also make a maintain harder choosing between the depends on the our product goals. So box, perfect cargo for the weather. Hinge connected to the vehicle. Fairing is minimize the air drag. Bed is support of the cargo load. Spring is suspend trailer structure which transfer the load to the road, is that way. the modular architectures are be work. So develop integral. So upper half so upper half is connected suspension trailer structure, perfect the cargo spring load, that way wheels the transfer the load, whole connected to the whole process will find. So another at the end of the transfer to load to the road. Integral product architecture. So integral product architecture function element and implement by the multiple chunks or of chunk by implement many function integral between the chunks are the poorly defined. So chunks are the defined poorly defined, so it is not a standardized or that wise. The integral architecture is generally increase the performance and the reduce the increase the cost of specific product model. So architecture is generally increase the performance and reduce the increase the cost of any specific model of product model. So multiple chunks may be implement maybe functions many functions. So that's why steps to establish the product architecture. So create a function model of the schematic product. First the cluster of element and schematic, make a geometric layout and achievement of the types of products variety, identify the integrations and the fundamental must be integrated initial. So to build the product architecture will be start to function model, a diagram showing that is the product must do. Next, we are group related functions into the clusters of the chunks. Then we make a geometrical layout or visualize how these chunks will be expositional and physical. Finally, we define the interaction. Some are the fundamental and must occur while the others incidents can be minimized. So next point is a design for assembly. The design for assembly is short form is a DFA. D for design, F for assembly is a A. So its short form is a DFA methodology. It is the pioneered by the Bothniard and DeWorst at the University of Rhode Island. So it is considered about the University of Rhode Island is developed the concept of design for assembly. So this method is design evolution and tools that enable to designers to the design product as easier or manual automatic handling in assembly, reduce the labor and time innovation for the assembly. So design for assembly is a concept generated by the University of Rhode Island. So that method is for uh, it is for general for the manufacturing for the design product for easily or manually automatic handling in assembly. So reduce the labor and time involved in assembly. So required the assembly time is reduced. They thought that concept, then design for the concept for design for assembly. So there is a YouTube video for the reference. So DFA is primarily for the cost saving tools. It is connected with the reducing the product assembly cost by the minimizing the part count, the number of assembly options we needed to produce the part by making this assembly of operations for easy to fail proof possible. So DFA is a primarily cost saving tools that is the concurred with the reduce the product assembly caused by the minimizing the part count of the number assembly. So operations needed. So design for assembly is a number of operations one together the one operation, it is the design of assembly. So whole assembly lines of number of operation performs like fitting, drilling, finishing, coloring, painting, um, testing, quality. So number of operations will be produced at the same time. It is whole connected to as a assembly line. So design for assembly, it is needed for the produce the part for making this assembly operations for is it well possible. So DFA is reduce the number of opportunity to fail any assembly operation to automatically lead and improve the design for manufacturing quantity as well as significant cost reductions. So DFA is the reduce of the number of opportunity to fail. So number of operation is divided by the separate department. So painting department, fitting department, manufacturing department, quality department. So number of departments are divided. So each department is clearly uh, say that, so that part will be designed. It is okay for the painting, it is okay for the quality, it is okay for the design, it is okay for the assembly. So number of assemblies, operations of assemblies created. So so there is a specific task for the only that part of. So need of, say one example of the paint section. So the body of car, so example of body of car paint shell is a painted area. So it is ready for the paint, it is the efficiency for efficient for the that department. So they will be the paint the part and transfer to the quality department of the check the paint quality. So the quality is checked by the paint. So test is done by, it is okay. So, how you are done, it is checked by the thickness of paint, it is the finishing of paint, like that. So fail, opportunity to fail is less for DFA, for design for assembly. The automatically lead to improve the design and manufacturing quality as well as significant cost reduce. So number of operations is divided in number of parts. So quality as well as cost is reduced by the separation of workload. So that's your work, you have handle it, that's your work, you handle it. So opportunity or stress of the work is divided to the whole line. They efficiently significant to the cost reduction as well as quality. So there is a one assembly, it is the whole their parts. So there is a whole parts, nuts, bolts, shafts, side balls, side walls, base plate, base nuts, rings. So there is a total 24 parts in 8 different parts. So multiple manufacturers and assembly process necessary. So there is only two parts, two manufacturing process, one assembly step. So there two drawings are, there is a number of assemblies. So one by one nut bolts are arrangement, one by one nut bolts are arrangement. So there is a multiple manufacturing assembly needed. So one assembly is fitting the nut bolts, one assembly is fitting the rods, one assembly is checking the quality of material, one is a painting department. So multiple assembly needed. So parts, more than parts, number of parts is equal to number of operation, is that clear? So second image, only two components are there. So one assembly is considered for that one operation only. So there is a difference between the, so design for assembly principles. What is the principles of design for assembly? There is a mainly principle DFA is a keep mind of are the followings. So minimizing the part count, modularity, build for fasteners, part symmetry, mistake profiling, use standard parts, use a reasonable tolerance. So there is a number of principles. So minimize the part count, modularity, etc. So, considering all of this aspect throughout the product development phases will be ensure the lower overall manufacturing cost into turn of the increasing the potential revenue. So, aspect throughout the product development. So, aspect, so size, shape, and size and shape to visualize the better look. It is the aspect of product. So phase ensure the overall manufacturing cost and increase the potential revenue. So aspect throughout the product is a main component through the turn increase the potential of revenue. So that it is the important for that DFMA. While a DFMA may be see some very produce the centric many of these features, we are also appreciated by the end consumer. So we are also appreciated by the end consumer by the DFM design for assembly lines. So go to the next slide. So design for the manufacturing. So design for manufacturing, it is short form is DFM. D for design, F for M for manufacturing. That is the design for manufacturing. And design for assembly, or we are already told D for design, F for A for assembly. So what is mean by design for manufacturing or design for assembly? So so we are integrate the product design and process planning into the common activity, like common activities. So the goal is to be design the product that essential the economical manufacturers to the import the designing for the manufacturing is underlined by the act to add about the 70% of manufacturing cost of the product. Cost, material processing and assembly are determined by design decision and production decision, such as the process planning of machine tool selection for the responsible for only 20%. So that is the importance. So important is designing for the manufacturing is about the 70% of manufacturing cost, and design for assembly is really about the 20% of cost. So most important is design for manufacturing, not as for, or consider the 70% weightage of the product, or design for assembly is only for 20% of weightage is carry, such as the process planning machines tools are the selection. So reduce the total number of parts, develop the modular design, use the standard component, design parts is multiple functional, design parts is multiple use, increase for the easy for fabrications, avoid the separator and fasteners, minimize the assembly direction, minimize the complement, minimize the handling. So there will be link or provide, go through the more detail for that ones, go through the link. So design for a process, DFX, design for X, DFI is a design for process. So first one is consider the so that one we one by one, so let's see why. So first one is design for manufacturing. So next one is design for assembly. So third one is a design for manufacturing and assembly. Fourth one is a design for reliability. Fourth one is a design for the quality. Fifth one is Sixth one is a design for maintenance. Seventh one is a design for testing. Eighth one is a design for the supply chain. Ninth is a design for the cost, or last one is a design for sustainability. There are the multiple roles are their process. So design for manufacturing, consider the manufacturing particles like material, paint, machining process, which machining process, which assembly is there. So assembly is which the location of the connecting that parts. So design for the manufacturing assembly, so design for manufacturing, so materials are selected, assembly are selected, it is the combined to get design for assembly, manufacturing and assembly. Design for reliability, so one consider is a one so one example case, consider the iron. Iron is a reliable product for the long life product, it is considered as a design for reliability. Design for quality, so use the design for manufacturing, like materials quality, it is the so with one of the ISO standard, ISO standard, international standards will be designed for quality. So design for maintenance, which product will be created, it is the easy for the maintenance. So one example is considered as an iron. So there will be for the light fluctuation, their coil will be faulted. So it change is easily for, it is change is easy way, that is concept is designed for maintenance or design for the testing. So one component are create, it is the created by the testing period. So consumer is directly affected with the product. So our responsibility, it is the safe or secure for before the handling to the customer, it is the department of the testing for the design for testing. So design for supply chain, so product are ready to dispatch for manufacturer to the customer, we need one supply chain. So there will become retailers, wholesalers, marketers, manufacturers, retailers, there will be one supply chain is created. So your product will be manufactured to dispatch to the customer, it is whole supply chain managed. So there is a design for supply chain. Design for the cost, so one product is considered the iron. Iron cost is 1000, or the next one when competitors are come, there will be sell as 800 rupees. So customers customers need a low value of money product with high high sustainability, high quality. So the product checked by customer is depends on the cost. So we are designing at the minimum cost of product, so design for the cost. Or last one is a design for sustainability, so the product is sustainable to the all weathers, all conditions, all fluctuations. Iron condition is iron press is a example is a fluctuation current, it is sustainable. So condition automatically connect cut the power supply for the power saving consumptions, it is part of the sustainability for long life of product. So product design and steps brainstorming, we are already speak on the unit number 3. Define and defining the product, conducting and users research, sketching prototype, it is the process of design steps. Sixth one is a complementing specification. Seven is the production of factory, sample testing, starting production, development, providing the quality assurance. This is the parts of that. So product design process. First one is a idea. Discuss with the client, market research, understand. First process with so whatever topic. So discuss with clients, the customers, they need want what is they need to understand that research, it is the first steps of the product design process. So using the next process is a define and correct project brief. So there is a part of one needs of customers, so define that one, or detail briefing project, create a deep brief project reports. So next one is a conceptual option. So idealize the concept, what is what way that will be work. So catches idea, create the visual brilliance, so visual conceptions will be created. So next steps is a develop. So next that will be that's sage that need customers of the need will be conceptual. It is one prototype to test the or analyze the whole parameters, will create uh, one parameter, one product. So develop the product, develop the conceptual defined design, it is the develop paragraph. So next one is a create a prototype, the 3D printing, CNC rapid tooling and prototype. So create whole design, it is 3D printed for the prototype, for aesthetics, dimensions, cost, there will be parameters will be checked and that. So next one is a creating the prototype, the test the prototype. So test that prototype, the needs of customer is satisfied or not, the production of cost. So whole parameters are be test. So whole that parameters are completely fine. So go next steps for the manufacture, the production of component, it is the need of it is the created the supply chain. So next one is a design for creative manufacturing. Next one is design for assembly, design for sustainability, design for reliability, design for cost, design for safety, whole parameters. So design for supply chain, again add then. So there will be first 5 steps of product design process is a main. So there will be pass of their pass with this their 6 steps, it is go for the manufacturing. So introductions of ergonomics in product designs. So ergonomics is a process which designing the organic workplace product and subsystems so that they fit the people who want them. Must be people here hard ergonomics and think is the something to do with the sitting with design car and control the instrument, and it is the but is so much is more. So ergonomics is applied to the design for every anything that is involved the people workplace and sport is usual or health or safety. Ergonomics is the process of design and arranging the workplaces. So ergonomic is the process to design or arranging the workplace, arranging the product, workplace of the product, and fit the people who use them. Most people have heard in ergonomics, I think something, what do you want, just sitting. So how does the ergonomics works? The anthropomy, body size, shape, populations, and the variations, biomechanics, muscles, liver, forces, strength, environmental physics, noise, light, heat, cold, radiation, vibrations of body systems, hearing, the vision, sensations. So applied the psychology, skill, learning, error, difference. So social psychology, groups, communication, learning, behavior. It is the, how does the ergonomics work? So ergonomics is aimed to create a safe, comfortable, and productivity workplaces by the bringing human ability to limitations into the design. For the workplaces include the individual body strength, body size and strength, skill, speed, sensory ability, vision, hearing, and even attitudes. It is the ergonomics. So polishing parameters, status 9 degree. So standardized shape, inventory. So there one is the image. For the more reading, please go for the downloads. Ergonomics in product design, go one of the best YouTube video we are suggest to you, watch the that part ergonomics in details. That will get greatly your helpful. So design for you in part print analysis. So that is interesting topic, that the idea of product design are convicted to this concept with the transforming them into the physical product using the part drawing, blueprint as a part prints. So part print, after the getting information in manufacturing, the process engineer must be study the part print, understand what is wanted in the final product. A detailed study of the part drawing for the manufacturing as a part called is a part print analysis. So understand what wanted the final product, understand what wanted in the final product. So detailed drawing for the manufacturing, it is the part called as a part print analysis. So part print analysis is a detailed drawing for manufacturing, it is called also part print analysis. The process engineer must be consider the following two important questions thinking the preliminary part print analysis. So preliminary part analysis need consider the two important questions. First one is what does the product design want? Designers want. So concept clearation. So the designers want what in the product. First question is that how does the product designers want? So designers want the product is what want. So what is the must be done with the information disclosed by the part print to get what is wanted. So there one is a two question for the importance making the preliminary part analysis. So this test is preliminary to extract the more detailed information for the part print. Essentially, the process engineer to seek determine the sixth thing of the this teacher. So general description of the part, the general configuration of the part, see the material from which is the part is made, how the part will be orientated, recorded change in design, resist to the damage process. So there is a detailed drawing of the manufacturing. So it is the consider the whole dimensions of the materials, selections, types, holes. So whole dimensions are materials. Whole dimensions are the mentioned at the sheet. So see, that is the holes, three holes at 6 diameter. It is the dimensions of that holes. So it is radius of the circle is 75 plus it is the plus minus is the tolerance of the design drawings. So 75 diameter of the circle with the tolerance of 0.5. So whole drawings are the that types. So classification of engineering drawings, element in product